On November 7, 1940, the Tacoma Narrows Bridge twisted violently in the wind, which caused it to collapse. It wasn't caused by an earthquake or an overload of vehicles, but an engineering flaw. The bridge connected two parts of Washington state and was one of the longest suspension bridges at the time. To reduce costs, it was built very thin and flexible. Its purpose was to connect the cities on either side of the Tacoma Narrows and allow vehicles to cross the water safely and efficiently, improving transportation and travel in the region. The Tacoma Narrows Bridge was 2,800 feet long with 39-foot wide roadway, made mostly of steel. Its narrow design saved money, but made it usually flexible compared to other suspension bridges. The bridge got the name Galloping Girthy because the bridge would twist and even bounce in light wind. This unusual movement was an early warning that the design was unstable. On the day of the collapse, there were 40 miles per hour winds, which caused the bridge to twist more and more until it collapsed. The collapse was caused by an elastic flutter. This happens when wind creates vibrations that grow stronger instead of stopping. Elastic flutter is similar to a musical instrument string vibrating. Once the wind hit the bridge at a certain speed, the vibrations kept building until the structure could no longer resist. The collapse came from multiple issues, such as the bridge shape-trapped wind. It was too flexible. Engineers didn't test wind effects. The wind matched the bridge's natural frequency, which created a feedback loop where motion increased until failure. The collapse could have been prevented if engineers used proper testing such as wind tunnels to detect any flaws. They could have used a better design such as a truss design to allow wind to pass through. They could have also used stronger support beams to support strength and stability. The bridge collapsed just 4 months after opening, causing significant economic losses and major impacts on engineers. The human impact was minimal compared to other disasters, with only one life lost. However, the economic cost was significant as the entire bridge was just destroyed just months after construction. Environmental damage is limited, but the collapse had a major impact on public trust and the engineering community. It raised serious concerns about safety and led to changes in design standards and regulations. The disaster changed how bridges are made, as engineers now use wind tunnels to test bridges and are designed to handle aerodynamic forces. The Tacoma Narrows Bridge collapse shows that engineers must test structures thoroughly so engineering disasters do not happen. Engineers learn to consider not just static weight but dynamic forces such as wind and traffic when designing suspension bridges.